Hello, my fellow YouTubers. This is Roy back again. I've been working on taking the Bedini, kind of analyzing it, and kind of thinking of it for a use into the electrostatic grounding system, I would call it, and also the Figueroa setup. And I came up to a couple conclusions. I wanted to show you guys how I came across some of the things that I'm about to show you and how they came about. And we're going to use numbers this time. I got tons of meters up, well, three of them. And those 3 meters will tell us what's going in, what's coming out. And what's coming out, we got two different types of setup. One setup is just going into a full wave bridge rectifier, and the other setup is coming into a voltage multiplier, and that's each one is hooked up to one of the bifilar wires. So we're going to go ahead and just take a moment. I'm looking to get some more peeps on. I don't see anybody on yet, and I will give you a little sneak. Going on, Adam in the house? I don't know what's going on here. Oh no. Know what that means? That means my transistor is burnt out. Let's check the transistor. It's cold. That's not normal. Not normal at all. Tonight we're going to do, Adam, some good tests here. And start off with, we got these 2 meters here. This one's going to read one of the legs coming out of the bifilar. This one here is going to be reading how many volts I have coming into the system through my car batteries, one car battery and a couple other alarm batteries. And that'll also show us the wattage and the amperage on both. This one here is a meter that's on DC, and it's going to read another bifilar that's coming out by itself. 2 wires to the bifilar, and well, had 2 wires. 2 wires to the bifilar, and it's not stepped up at all. So you'll get to see the voltage I'm dealing with. And this is basically tied to how much resistance I have in the multiple wire coil. We'll get into this. I'm going to get into all this. But if I need to change this transistor, I want to do it now without reading everything. So I'm just going to hook it up one more time. If I touch this and it goes on, let me see if I move this out of the way. Yeah, that's not good. That means the transistor gate's wide open. Used to that, you should see how many transistors I go through experimenting. I buy them cheap online. So I'll also show you guys. I don't even need, let's show you guys how to build the Bedini transistor. Yo. Because why? Because that's what we do around here. All right. Here is the transistor. Let's get the pieces to Mises. I got we need two diodes. We need, notice I have them out because I blow them. I blow 20, 30 of them at a time. That right there is a neon light, AC light bulb, 12 volt. And I believe we're good there. Oh, no, we're good. We're good. All right. What's going on in the house? How come I got nobody on? But I'm going to show everybody how to make a Bedini setup here. This is a 2N3055. All right. This side, if you look at it, the two pins are higher on the whole kind of weird shape. And they need to be on the top side. Not, you can see that's low, that's high. So you want them on the top side. And to the left is the base. Hey, Tommy, what's going on? Tommy Tom in the house. To the left is the base. I'm showing everybody how to make the transistor setup with the Bedini wheel. Real quick. I just blew out my other one, so didn't get a chance. I know. Well, it only shows one person on, and you guys are talking, so it's more than one person, at least on my phone here. So to the left here is your base. To the right is your emitter. We're going to take this transistor, and the size transistor is I don't know, it's a 407 or something like that. I got to wrap it around where you got the ribbon side towards the base. There you go. Now you guys bouncing in, bouncing out. And then you got that'd be your negative side. That'd be your pot. No, that'd be your, that's the ribbon side. Then you take the other transistor and you send the ribbon outward from the transistor and just connect it to the collector. And the chassis is the collector, which I know I didn't even mention the chassis. So you have this diode connected to the collector plate. The emitter is connected to the negative side of the whole circuit. And what happens is the emitter side is the grounding, and that means that the collector plate is pushing out a ground connection when it clicks on. So the diode is pushing out a positive on the end here, and that's going to go to the charging battery or whatever you want, but that's the positive side of your circuit after it comes out of the transistor. So we're going to take this little neon light and we're going to wrap it on the collector side of the diode. Then we're going to take the other side of the neon light. It's a 12 volt neon light. Remember, it is an AC light. We're going to wrap it around the pin for the emitter. And that there is, if you unplug the top side of this, is the positive going to your battery, or how you can see how I'm running stuff. And then the other side is your negative side, then you'll have your goings out here. Your back EMF hit pretty much goes out this side of the collector and one leg of the battery. So we are all set here. Let's go ahead and replace the one that I have here. That's this one here, so I'm just going to reconnect stuff. So this here is going to one leg of I got a light, a 4.5 watt light, instead of going to a battery. And then I got this leg here is going to the negative side of the battery. This here is going to the tail end of the smaller wire on the coil for the trigger wire. That goes to the emitter side. And the collector comes out, and I connect the connector right there. So it kind of clamps this down better. And the only thing we're missing is the trigger. And that here is another light. And that's that little light you see, which they call, this is a grain of wheat light. It's a 12 volt DC light. And that will tell me which side the wiper of the resistance of the little potentiometer is leaning. And it's either leaning towards putting more current towards the output of the, say, of the charging battery or the back EMF, because it adds more voltage to the coil, which puts more juice into the core, which comes out more juice, and we'll go through that experiment. All right, so we're all set right there. You guys got that? There goes your Bedini setup. And now we're going to connect the battery. All right, now that flash was a good sign. Not supposed to stay on, so the transistor's closed. One thing I want to show you guys is, here's my new coil setup. It's a 10 filer coil. It's got a laminated core. And right now we're using the one leg is going as a driver, so leaves me 9 other legs, and one leg, no, leaves me 8 of these legs, and the other leg is the smaller wire, and it's the feedback. So pretty interesting. And if you ask me why am I have 8 extra wires, well, I've come up with some idea of getting rid of the commutator and sending each one of these as strikes into the Bedini, or into the Clemente Figueroa setup. And as I investigate more into the Figueroa setup, I believe to be true is the patent is wrong. The patent does work, but it's too much resistance. If you think about this, all 7 and all these 7 are in series. Now these collectors in the middle, which would be the conductors, are in series as well, which gives you a 1 out here and a 1 out here on wire. These are all in series. So when I calculated the resistance at each side, I was at about 32 ohms. And that means that a total of 64 ohms between the bottom leg and the top leg. Are you kidding me? What the heck? I don't think you really need that much resistance to make a sine wave by using DC pulse. So I came up with an idea of using the 10 filer and leaving 8 legs. And what I'm going to do is bring out a little bit of some slowing down. We're going to put a drag on each leg of the resistance. So each connecting to each part of the resistance is going to have a capacitor. That capacitor is going to put a lag. So if all these are being fired at one, with each one having a capacitor and a different size capacitor, the smaller capacitor will be like a instant hit, and then with a capacitor, a smaller one, it'd be a slower, and then a bigger capacitor would be even slower, and bigger capacitor. So basically, I know that sounds ridiculous, but that's how I envision the energy coming out of this 10 bifilar, because 2 are one's a trigger, one's a driver. The other 8 are going to be going through this system. Thanks, Marker. Yeah, it is a symphony. You can't have a break. You can't have a break, and that's why in electromagnetic waves, there's nodes, and these nodes are they show their face if you take a string, tie it to the wall, pull the string tight, and flick the string, and as you pull tighter, you'll see different balance points or different low points, and the more tension you put on there, the more nodes you have. And you don't want nodes here, because the sine wave is just a smooth, ongoing, and it's a perfect circle is what we're looking to create here in an electric magnetic way. So cool stuff. All right, so we talked about this, which is the 10 filer, okay? And I noticed a lot of shake in the wheel, and just having it on that tall thing like a Ferris wheel look good, but practicality, no. So I put it down, I put it on this little Baron, and the Baron was off of one of those washing machine motors, and it has a good Baron on it. So I attached this to the Baron, and uniquely the way I have it set up now, all I have to do is move the core towards the coil and just give it a little spin, and it instantly starts the whole system the way I have this set up. So let's go through the system, how I have it set up, and we'll work from the wheel on out. Okay, so you have the wheel, you got 8 1-inch square cube neodymium magnets. You got a 10 bifilar coil here. I have this block. I have this all screwed to the block, and the block with 1 screw in the back, so the block pivots. And by it pivoting, I can bring the core closer and further away from the magnetic field of the cores of the magnets. Very important. It's a very good variable to have here, and it'll show up on the back end. And right here you can already see one light's lit up because we connected that battery over there, and you've seen that blink of a light that shows me the transistor had a little action, but there was nothing to kick it back on, so it went off. Over here, oh, that's not good. Something just disconnected. Oh, that's good. That's fine. So how do I got 49.51 volts, 12 volt car battery, and 3 little 12 volt batteries? Now, obviously something's a little on the low side, but they were charged a couple days ago, but I've been doing a lot of experimenting. So right now you got 49.51 volts is going to run the Bedini. Now once we start turning the Bedini, this top one will come on. And when that comes on, that's going to show 2 things. I'm coming out, we're just doing tests, and this is cool test. We're going to show a couple good things on this core and the magnetic field, and how we're going to be able to still have the wheel turn by not hitting core to core. We're going to be hitting here out of this core into the magnetic field of that core, and it's still going to turn the wheel. Very cool stuff. I got the tachometer set up. We do have the potentiometer. Right now she's all the way to the right. We'll leave it like that. So the wiper blade's all the way throwing the current towards the coil. So the coil has the current right now, not so much the light. This light right here is where the back EMF of this coil goes into, which we talked about in regards to the the transistor. We're coming off of one leg of that diode, and that diode's facing out, and then the other leg of that is connecting to the positive. So that is the negative. So that ring facing out is the negative side, and but it has the diode in there, so it's not going to get a kickback into the transistor. All right, so let's so we're coming out of one wire, which has two ends, is going into this full wave bridge rectifier, and there's your DC out. We're treating the wires going in as AC, which is DC pulse, and that is going to the voltmeter. So we'll see what the actual volts are that are coming out of that winding. Now what I did here is I put 675 turns on the driver wire and the feedback. That's a lot of wire. It's the driver wire's 23 gauge, the feedback's 26 gauge. Big difference in resistance. I think the resistance on my thumb, which is I think is 8.4 ohms, and the resistance over here on the feedback I think was 23 ohms. So you guys know. Now on the 8 wires, no resistance is showing up. I'm only doing about 75 turns. No, 100 turns. Not a lot of wire. So it's just wide open, whatever current it can get going in. FYI for you to know. Now, the other set of wires I got coming out is going to my voltage multiplier. So coming out of my voltage multiplier, whatever volts that is, it triples it or doubles it. I think it doubles it. I think this is the doubler setup. And I come out of that, and it goes into this meter, which ain't on because the wheel's not turning. And it'll show how much volts without a load. Now I have as a load, this is a 12 volt motor, DC motor in there. And what it does is it's a vibrating plate. It vibrates, and it's good for different frequencies and materials moving, like that string we talked about. So I'm going to go ahead and disconnect one leg of it, because first we're going to just show, without that load on there, we're going to just show the volts coming in. You guys ready? Do I get a thumbs up? No comments out there. Am I talking too much? I don't see any comments. Alrighty. Anyway. All right. So thank you, Marker. So let me see. I'm standing in front of this wheel, and I don't want this shit to fit. So we're gonna go this way. And I'm just gonna move this a little bit close. Oh, really? Let me check again. So maybe I can't have the battery hooked up. Oh, hell. Oh, it's working. All right, so anyway. All right, so we'll move it a little closer. We'll get some speed going. And remember, the light right there is the back EMF off of the transistor and the positive leg of the battery, okay? Alrighty, so let's start off with all balls to the floor, and let's just move. Oh, don't want that going up. Oh, hell. We don't connect that. That transistor is going to blow up. Fire in a hole. Yep. Blew out the transistor. Oh yeah, she's hot. All right, so bear with me. Race car, we're gonna make another transistor. That's what we do. And basically I got a graveyard of them. I probably have 100 of them. I got a graveyard over here. And I don't take the pieces off until down the road. So here's one of my graveyard ones. I'll throw it over there. I'll just get, I got the big bag. You know, this whole bag of neon lights. This whole bag of neon lights was like $6. All right, two transistors, two diodes. It's like a pit stop, Roy's pit stop, we'll call it. There's some cool experiments coming up, especially when you get to start to see the numbers on the current going in, driving the Bedini coil. And you really got to know your math and do your numbers on your size wire and the resistance you're looking for, especially for your output. And you got to know how many amps you can put into these 2N3055s. Look at this, we're almost ready to send the car back out the track. I'm gonna put some tape on that. Here we go. Another one bites the dust. Let's get over here. All we gotta do is replace the connections. And that one it's still hot, so I won't throw it in the pile. This grain of wheat light. The wire is so fine. And it's springy. It's hard to get on. All right, there we go. Let's make the connection, and we're just gonna. We gotta tape this guy. Yep. It's a strong magnetic field. All right, that ain't letting go. It's amazing, these magnets, what they pick up in the room. Hello, hello, hello. All right. Fire in a hole, guys. You can see the gap I have. Can you guys see that okay with the light? Yeah, you do. So, a couple things with the light is that you get to see the stretching of, these are like, almost like nodes in a sense. You see one line, 2, 3, 4, 5 lines. I can't say they're nodes actually, but there's something there that I wanted to show you guys. Especially, look at the RPMs, the tachometer, right? Let's look over here. There goes the top voltmeter. Let's look and see what we have. So, this right here is what's driving the Bedini. So we got 48 volts going in, okay? We're 0.42 amps, and we're at watts we're at 20.6 watts, 20.2, 20.1. Now we can adjust that now, but let me just stay here for a second. Now this is the power going in here that's coming off of two of the windings, right? So this winding that this one is representing is the winding off the multiplier, okay? Because this right here is what I first got when I first started. So this voltmeter is representing 2.25 volts. 2 volts is what I started with. And I figured out I'll multiply it, and I brought it up to 12. So that means I was getting 6. I don't get it, because that means I have a tripler set up then. I must have forgot about putting an extra, I think that's what I did, because I think those 2 capacitors, I think that's the doubler with 2, and I think I did a tripler with 3. So that makes sense, because at 2.26 times 2 somewhat comes up to 12.35 volts. Here's your run winding right there. There's your volts in. There's your power out going into the tripler. And let's go ahead and put a load on here. Now this motor here, remember, it's a 12 volt motor. So we're gonna see this. Can you guys, let's get you honed in, my bro hams. Happy Sunday, by the way. Let's get you in the numbers here. So, well, I want you to see that sucker vibrating right there. So let me get you up just a little bit. There we go. What's going on, Jason in the house? Sunday, yeah, it is Sunday. My son, we're the sun. All right, so we're gonna put a load on here, and this top volt's coming in out of the Bedini. There's my vibrator motor. Drop down in volts. 9.54 volts. The current, 0.4 watts, 0.04 of an amp. What's going on, Angel, in the house? I don't want it to drive away on us. There we go. That will keep it from running off. So you can see how we have 9 volts. Now we're gonna do this. We're gonna actually, all we're gonna do is pull this away so the induction on those batteries, on those magnets, let's pull it away. Let's keep, well, you guys can't see that, can you? Let's pull it away. Let's pull it away till it turns off. It's still on, guys. Look where it's positioned. Not even facing the magnets. Not even facing the magnets. You see the tack drop down. Yeah, it slowed down. That's what I want to show you guys. Now the volts went down over here. Look, it turned off. Now, we stretched that field out, didn't we? Now, I just pushed in just a little bit. Now you can see the volts was dropped down. So this makes the whole system here variable. It allowing me to pull those 2 inductive, that inductive and that inductive magnet and that core away from each other. Like right now, it's still got a good, look at that. It's not even, it's aiming this way, so it's pushing the wheel. You can see our tachometer, we slow down in speed, and it shows in voltage. Ironically, we're at 8.29 volts with a load, and if I take the load off, which is a noisy load, we're at 11.54 volts. Let's check out the other part that I didn't really check, is let's see if the load is reflecting on the driver coil. All right, let's do that right now. Let me get my hands free, guys. So we're gonna get you positioned right here. So we're gonna put the load back on, and we're gonna see if the driver coil, and that would be the lens effect. How would it be the lens effect? Because we're pulling energy from somewhere in order to provide energy here. So a couple things should happen. Let's take note here. Let's take note here of 0.17, and then let's take note here of the speed. So right now we're still dropping. Let's give it a little bit more. It seems to be slowing down a little too much. Just pushed it a little bit. Speed's going to increase. Not like we need the speed, but you can see as the speed goes up, the volts goes up. But I believe it's the induction that's causing the speed. So you can look at the positions where everything is sitting. That the induction is driving the speed, so the speed falls secondary to the induction. So as I move this closer, the induction is causing more voltage, which is causing more speed, more induction inside the core of that coil. So let's go ahead and put the load on, and let's check to see if that tampers anything. So speed right now, it's still rising. Let's let it rise. I shouldn't have turned it. Let's let it get comfortable before I try this, because I want to see if it puts a load on this coil's driver. What's going on, Anthony? Yeah, I love those Variacs, especially building them or repairing them. I like that, Ross. I'd be part of that. I'm sure everybody on this channel right now would be. All right, so we're harboring about 11.5 and change. What's going on, Angel? So 1100. Well, the RPMs now went up to 1180. So it's traveling up. Let's go ahead and connect the load. All right, so the volts is dropping. I did see this change here, 48.37. So we're getting a voltage drop in the batteries, which is the bottom one, is what the battery charge is. And here in watts, we're at 14.5. Let's disconnect the load. There you go, guys. Proof's in the pudding. Power in, power out. You're not getting anything free here. But it's not about finding free power here. You know what it's about? Experimenting. Now let's go ahead and get that volts up. I'm going to do that by pushing the induction closer. So you guys stay there, and I'll push the induction in. You can see the voltmeter go up on the output. Now I'm going to get into the potentiometer. I'm going to turn the potentiometer all the way to the left. Put out your email. That's how we'll make a list, get a list going. Post your email. Oh, I didn't mention this. I got a capacitor coming off the output of this. And that motor is running off the capacitor. If I didn't put the capacitor in there, let me show you. So if I don't put the capacitor in there, watch what happens here. You can see the volts bounce back up, right? And let's eliminate the capacitor. I got it connected too good. It runs the motor, but the lights go out here. It drops the voltage down to 6. So the capacitor allows that to run. Let's get that noise off. I got some other electric motors here. Here's one right here. It's a 12 volt. Can you guys see that spinning? Running that motor. And that motor is only running off of voltage tripler and one leg off the Bedini. We'll let that, and that load, let's see, look at the load drop with this. This load drop will be more, so this is a big motor. So if you look at the volts here, we're at 11.40. Now I can go ahead and connect this, and it drops it down to 7. You see how that light went down? Because of that capacitance right there, it balances out and keeps this motor running. Now, if I take the wiper blade and if I turn the potentiometer to the right, what it'll do is send more power towards the coil, and we're going to see the volts go up. So let me put you over there. You can see, watch the numbers here. And let's look at the watts and the amps on the driver coil. So as the driver coil, you can see this turning. As the driver coil increases, because I'm putting more resistance in the system and taking the wiper and put it all the way to the right. Now you just seen the power of the watts go up, the amps went up, and now you see increase on voltage with this motor running. So it goes to show you there's a lot going on with the resistance. That motor is just going to stay running as a load. And we got a lot of distance here for inductance. So let's go ahead and I'll start moving the wheel closer. And let's see what increase. So we always see we're at 1800. That one coil is only putting out 1.88 because the inductance separated. When you get into voltage multipliers, you see that you could step up the volts. There probably is a limitation on the current, but we're not really concerned with that for right now. And right now we're going to make that induction better. So let's watch the meters here, and we'll see the watts go up, the amps go up on the driver coil. This is the driver coil, and this is the power out. Okay, let's move it in. And And what we're going to do is we're going to let this balance out, and then we're going to get into the potentiometer, and we're going to find resonance in between both sides. Because right now we're leaning all the way to the right. So we're sending a good portion of the current, or all the current, well, a good portion of the current into the coil. So here you can see the volts coming in from the batteries. You can see the watts that we're driving the coil with. You can see the amps that we're using for this. Then here you can see the coming out of one of the coil, or one of the wires of the bifilar with a load. That's a big load. Now if I take the load off, watch that increase. Now you'll see that increase without the load. So there's no load coming out. We're just recording. The 0.02 is what this light LED is using as a meter, because there's nothing coming out of that other than what the light or the digital meter is reading itself. Let's go over here and check out the TAC is at 26.9. We have a lot of gaps still there. Let's go ahead and, you hear that? Tachometer speeding up. The single wire, 2.25 volts is going up. The last time we checked. The volts is staying consistent over here. Power going to the driver is staying consistent. Speed's increasing. As speed goes up, we should see volts go up. A little closer. Listen to it humming. It does sound like the ultra spin cycle. Damn it, man, that's a good call. It does sound like that. And holy crap. It does. I'm waiting for my washing machine to start rocking across the floor, for Pete's sake. We went up. We're climbing on the power we're driving that coil with. The amperage went up. I think it was 0.42. The watts is going up. Let's put a load on the here and see if we have such a bad drop. Load's on. Speed's still climbing. Let's see if I take the load off, if the speed goes up. Let's go a little closer, guys. Sounds like you just stepped it up a notch. Speed's not increasing. Speed just went up. That's almost straight on magnet to core. Magnet to core. Let's just put it there. Look at the speed, went up to 34, 35. Oh, she's starting to get a little, oh yeah. Oh yeah, you hear that? Holy cannoli. Whoa, doggy. Look at that. Oh yeah. I think she found a home. She humming, staying steady. Let's check out what's going on here. Look, we're almost at 3 volts. 0.298. Look how much wattage we're using to run that coil right now. 29.8 watts. 0.63 amps. Got no load going here. See if I put on the shaker motor. Well, you know what would be good is putting another light on here. These lights, man, it's like they find real good resonance with running these lights. I don't know what it is. Not that one. Oh, that's a dead one. Oh well. Got some current coming out of that coil. Got some current coming out of that coil, guys. So this was all about straightening out that tower, finding a better setup. Oh, by the way, in Florida, we have a river. It runs from the north side of the river to the center of, almost the center of the state. Probably 200 miles, and it runs north. Runs uphill. It's called the St. Johns River in Florida. Look it up. It runs north. Staying at good speed now, guys. Now let's do this. Let's stretch out this magnetic field. Let's pull this away. Now everything's still humming. That's coil still humming. Look at the angle we're pulling away from. Let's just watch the RPMs. You got the load still running. Still pushing good current out. Now we're only using 17 watts, 16 watts and dropping. Look at the watts dropping. That's running the coil. Now it's bouncing up, so we're getting to a balance. Wheels still turning, will stay turning. That's your heartbeat right there with the grain of wheat. There's your volts coming out of one of these bifilar. And the other one running the current is coming out of a tripler. See that, where it picks up the magnetic field? You see how far away I am? Yeah, that noise is the load. Turn that damn noisy thing off. Sorry, guys. Time for a pee break, my brohams. P breaks over. Oh, look at that. It's amazing how a magnet can unscrew a bolt. Look, it's unscrewing the bolt. That's the tachometer probe. I keep having to tighten it up. It'll unscrew that nut. Look at it. It's already starting. You guys see that? Right there? It's already starting. Look how far away we are. If you look down, you see how that wheel is just perfectly balanced, I guess. It's got a little wobble to it, but so you can see the magnetic fields coming out of that core, and it's pushing the field out here. It's not pushing the core of the magnet anymore. Pulling it further away too. It's pushing the field. So that field's got some elasticity to it. That magnetic field of those neodymiums. And pull it away a little further. If you want a better reference, you can see right now it's pushing. Look at the direction. That light's blocking, but look at the direction that the core is facing. It's almost 90 degrees off of the magnets facing it. Slow down, look at that. So if I go back a little bit further, well, I wanted to share this with you because I've been not making any videos in the last 5 days or so, and between work, family, and these studies, to break it down with this Bedini, well, a moving electromagnetic field, switching on and off. The other thing I didn't really post to you guys yet, which to me is just a whole nother story in itself, is that if you take the core out of here, the transistor still switches, and it switches at the frequency of the coil. And I could, on my next video, will take the counter on my SIG generator, and we'll connect it to that coil. We'll push out the core, and you'll see the frequency of the coil. Well, I can do it right now by just using another coil, to tell you the truth. We'll just pick this coil, for instance. All right, there you go. No load or nothing. We're just going to pick this coil. And let's go ahead and turn this off. All right, get that light out of our face. I'm going to disconnect the power going to the transistor. And we are just going to transfer over. Can you guys see what I'm doing? We're just going to transfer over that transistor to this coil. And pretty much the black tape means that's the start, okay? Now what I do is you got a fat wire and a skinny wire. The fat wire is 23 gauge. The skinny wire is 26 gauge. This coil, I didn't do the ends. Let me get one that I have straight down already, like this one. The same coil. These coils are all identically the same. And this one I have the ends done. All right, so here's the start. So we're we're looking for, how are we gonna do this? We are going to just feed off of here. So this is the start. Okay, so the start over here is going to be the start skinny wire. So this right there. So we're going to go there. That's the 26 gauge. And then we want the fat wire, which is over here. So the fat wire here is going to connect. This is crazy that I know this shit. The fat wire there is going to connect to these doubles. And there we go, we're loose. And we're going to connect that to the start fat wire, the 23 gauge. I'm going to set that coil right there. I'm going to show you a couple things. Adam, you got me going here. So when I get this coil going, we're going to connect it to the frequency counter. We're going to see the frequency of the coil, and I'm going to bring in some different metals to go near or in the coil. And we're also going to take a magnet and stick it in this coil. We're going to look at the frequency and see the frequency changing from different metals. And one thing I will say is iron, as soon as you bring it near it, the saturation of that kills the coil instantly. And how we restart the coil, I throw a magnet back through the coil and it restarts the coil. You're going to love this, guys. You're going to love this. All right, skin back to this. Now on the skinny wire, over here we are at that's the fat wire. So on the outs of this, the skinny wire is going to go to this skinny wire. And the fat part of that wire goes out to the collector. Bam. Now we're set right now. So let's get the SIG generator generating. You guys ain't going to be able to see the frickin', you're going to have a problem. Let's put this right there. The SIG generator's right there. Let's get this thing plugged in. Let's see if we can get you guys to read it because of the glare. I don't know what I've been told. All right, so what are we going to check here? We are going to come out of we're going to go into the light bulb. There's a couple different ways we can tap into it. We can tap into the collector and the emitter, or we can we're going to come out of we're going to go into this light. So this is the back EMF light, all right? This is how we're going to do the first one. So the light is going to set the frequency that's in here, and we have to go to, can you guys see that? Yeah, you can. Bam, hit this over to frequency counter. All right, now let's go ahead and connect the power. What are you guys going to see? I'm going to put you here to this, because as soon as I connect the power, you're going to see something happen there. It says 0 hertz right now. You guys see that? Let's see what happens. All right. There goes frequency of this coil. which is in kilohertz. Hear the humming? Uh-oh, we just killed it. We got a smoke down. Unplug. I know what the problem is. Damn, we just fried it. All right. I'm just gonna say this. It's a little late, guys. I'm a little tired. We're gonna do this experiment, but it's great. You can see that the coil fired up itself. And the fact that, well, maybe we can get it going again. Let me just get one more hurl. I think I burned out the transistor. Transistor's not even hot. What could it be? Maybe we back down on the voltage. How about that? Instead of going with all this voltage, let's back it down. Get that gone, get that gone. And get that gone. So basically, I think we are negative out. Where's the negative? Let me see what we got here. Got anything? Nope. Nothing there. So we don't need the tachometer anymore. We just need the negative there. Let me just coming over to the negative, and we need a positive out, which would be this wire. Transistor on. But not yet. Let's take this magnet and let's run it through the center. You hear it? Now, look at the frequency here. You got it restarted. So the frequency's restarted on this whole setup. You guys see that? 1.270 kilohertz. This coil is running. Now I'm going to take this magnet and I'm going to put the magnet in towards the hole and watch the frequency. Look, the system turned off. Well, the system's on again. Why is the wheel turning? Interesting. You hear that? Listen to the sound of this coil. Listen to this sound. I'm going to turn the potentiometer up. Look at the kilohertz. Down to nothing. 0 hertz. I'm going to turn the potentiometer up. Nothing happens. Still 0 hertz. Now watch what happens when I take that magnet. Let's get this thing running again. Watch this. I'm having a problem, but watch. All right, well, obviously, I either disconnected something or burnt. Oh, yeah. All right, let's connect that right now. So this is the tickler wire. We'll call it the feedback wire. As soon as I put that on. This is cool stuff. Let me put this magnet right here. And we got to get this wire back. Let's see if that's enough to get it going. So we're going to take the magnet. We have 0 hertz going right now. Let's go on Explorer. Let's go ahead and restart this. Here it is. Look, the lights, look. Light came back on. Hear it humming? Frequency. 1.28 kilohertz. Now let's go ahead and pull this magnet out. Hear the humming? There's a node in there. You hear that? Okay, so the light's on. So that means the coil's running. The grain of wheat light is on. And the frequency is 1.28 kilohertz of that coil. Now, you guys seen what the magnet does. It restarts the coil. Light is on right there. Let's come over here. So we are putting 23 volts into this coil, and we got 12.9 watts, and the current is a little bit over a half an amp. 0.56 of an amp is what we got running through here, and we're generating. Oh, it went out. What is going on? Let's go ahead and see the light just go out. Now let's reactivate it. I'm going to go up from the bottom this time. There it is, just kicked on. The light kicked on. No frequency. Oh, there it goes. 1.287 kilohertz. Light's running, coil's not hot. So right now the transistor is finding a medium resonance in the coil. And there's your frequency. So now it's dropping down. Seems to be losing itself. The light's still on though, so that's not a good sign. So let's put the magnet back down it. I want you to listen to it. It's got a sound going. Ready? Can you guys hear this? Now this is pulling it down. You can hear it faintly, right? Now this is the same pole, so I'm forcing it in. When I go to force it in, you can hear the coil humming. So that's a magnet, right? And for some reason, we're not even showing frequency. Now let's go ahead and get the frequency back through. So now look, the magnetic field of the coil is holding the magnet in there. The magnetic field is holding. Have a good night, my brohams. Leave your comments.